Right, okay, in this video I am going to be hardwiring a CT clamp into the myenergi eddi. Right, the reason I'm doing this is that in our setup we've got a myenergi Zappi, you probably see that just over here, that's attached to the garage. And we also have a couple of Tesla Powerwalls just down here on the side of the house, as well as some solar panels on the roof and a myenergi eddi near the hot water tank inside the house. We've had this set up for quite a long time and it's worked really, really well. But the only limitation we have is because the Zappi is over here and the grid, the meter box is over here, we can't directly hardwire a CT clamp into the Zappi. And because of that, we've been using the myenergi Harvi instead as a wireless CT clamp. That works really well, except that there's one small limitation, and that is that the myenergi Harvi can only monitor 65 amps worth of current coming into, or well, via any of the CT clamps, so coming into the grid via the grid connection, via the CT clamp on the grid connection. That hasn't been a problem up until very recently when we installed a second Powerwall. And now with two Powerwalls, the Zappi and the eddi, when we try to charge the Powerwalls, charge the car and heat the hot water on the off-peak electricity overnight between 11:30 p.m. and 5:30 in the morning, we will very regularly exceed that 65 amps. And when that happens, the Zappi will start to throttle the amount of power that's going into the car to try to ensure that we don't go over that 65 amp. In reality though, we've actually got a 100 amp connection to the grid. So essentially we're missing out on 35 amps worth of electricity that we could be consuming in that cheap rate electricity time. So the way to get around that is that 65 amp limitation is specific to the myenergi Harvi. And if instead of using the Harvi, you instead hardwire a CT clamp into either the Zappi or the eddi, then it can measure or monitor up to 100 amps. That will allow me to increase the grid limit within the system and therefore consume more electricity overnight during those cheap rate hours. So let me go and show you the setup that we've got, and then we'll get on and actually start to install it. I appreciate that many people watching this might just be interested in how to actually hardwire the CT clamp into the eddi, so rather than the actual way that I've routed all the cables and all the rest. So what I'll do is I'll leave chapters in the video so you can jump to the section that's most useful to you. And also, if this video has been useful, please do give it a like and subscribe. It's really, really helpful for small channels like mine to make sure that my videos can get out there and people can find them. Right, let's get on with it. Okay, so here you can see we've got a couple of Tesla Powerwalls and the electricity meter in here. And then down here, hopefully you can see that, here's the Harvi. Oops. There's a whole load of cable here obviously for the solar and the Tesla gateway and all the rest. But the Harvi is connected to this CT clamp here. So that then reports back wirelessly to the Zappi and the eddi. Now, fortunately, the eddi, the myenergi eddi, which we use to divert solar into the hot water tank, is directly on the other side of this wall. So it's about, I'm going to guess it's about here-ish, behind this wall, which is great. So what I'm going to try and do is hardwire a CT clamp into the eddi, which I believe then will allow the myenergi system to actually throttle or recognize that this is a 100 amp breaker that we have here, and then to try and manage the amount that's charging the car or the eddi based on that 100 amps, not on 65 amps. So that's the plan. Now I'm just going to work out how to make this happen. What I'm going to try and do is I've got a couple of holes into the room that the eddi's in, and I'll show you that room in a second. Down here for these cables, this is these brown cables here go off to the satellite dish that we don't actually use, and these network cables down here are used to network in the Tesla gateway and the solar edge inverter, plus a few other things on the outside of the house. So what I'm going to try and do is feed another cable out through one of these holes and then attach it to this group of cabling, make it go along, and then probably make it go up through that conduit there into this. Somehow try and get it through this hole into the bottom of the consumer unit, or into the bottom of the energy meter enclosure, and then replace that CT clamp. So that's the plan. It's never quite as simple as that, obviously. So I'll have to try and work out how it's going to actually work, and see what happens. So yeah, let me take you into the inside room, show you what's inside there, and then we can try and feed this cable through. Right, in this room, I've got all my consumer units, my electricity consumer units, as well as the boiler and the hot water tank and all that kind of stuff. And over here to the left, I don't know if I can show you that quickly. I've also got my comms equipment, which is in a complete mess. So, but for this video, the most important thing is this eddi. So we've got the myenergi eddi here, which connects to the immersion heater in the hot water tank, which is just over there. But this eddi is on the other side of the wall to where we were outside with the power walls and everything there. So if you look down here, you can see these cables here. These are the brown and the brown satellite cables, the network cables, and then there's also a couple more satellite cables that come through here. So my hope is, hopefully you can see that. Yeah, fingers crossed, there we go. My hope is that what I can do is fit another cable out through one of these two holes. They're both sealed on the other side, so I'm gonna have to break that seal and then reseal it afterwards. But push out another hole there, push another cable through there, and then wire that directly into the eddi here and get the other end of the CT clamp around the mains live cable. So let's see if I can put all that together, and yeah, let's see how we get on. Let me just show you in here. So if I go into menu and then down into device settings and then into installer settings, let's quickly type in my password and then come back, or passcode and come back. So I've typed in my passcode, then go into supply grid, then go into network, and you can see here the import limit is set to 65 amps. If I try to change that, I can go down as much as I want, set it to 60 amps. But if I try to go up, it goes back to 1 amp. And really annoyingly, it won't allow me to go back around to 65. Instead, I have to go all the way back through. So let me quickly do that now. All right, so I've set it back to 65. So hopefully, once we've hardwired the CT clamp into the myenergi eddi, I should then be able to change this up to 100 amps. So let's see if that works, and yeah, fingers crossed. So I need to get the cable. First job I need to do is get the cable for the new CT clamp from inside the meter cupboard into this trunking underneath. There's a hole down here, which is in a bit of an awkward spot, but luckily there's already a CT clamp going through. So I'm just going to attach this cable to the CT clamp cable and then pull it through. Hopefully it will just go through pretty easily. So let's see what happens. Okay, and that's gone through. Okay, so now with any luck, I can just pull this cable all the way through. Right, so I have not put the CT clamp onto the cable yet. I'm not entirely sure whether that's necessary or not, but I'm a little bit worried that if I put it onto the cable, it's going to induce a current, which then means that I'm working with a cable with a small current, which it probably is okay, but I just don't want to, I'm just not going to risk that. So instead, I'm going to leave that off and put it in at the very, very end. So let me close this up for the time being. So now I need to run it across this box and then down this pipe here, which then gets me down to the cables that are running along down here. I don't know if you can see that. Yeah, it gets me down to, you can't see that at all. Hang on. Down here, there's some cables that I can then run along and then go in through this hole over here. So let me see if I can do that. Okay, excellent. Okay, so the cable's now going across here. So it goes from inside the meter box into this trunking, across this pipe, down through here. Now I just need to feed it across the wall and then go inside the house. So yeah, I've got to deal with all these spiders now, which is not so good. But let's get on with it. Okay, so here's the cable coming along. I'll need to cable tie this down once it's all in. But now I need to get it inside the house, and I'm going to go in through this hole here. I've already I try to use one of these super rods, but the hole is just too small, unfortunately. So what I've done instead is I've got an old coat hanger that I've poked through, and it's coming out into the room underneath where the eddy is. So now what I'm going to do is try to attach this to the rod. Oops, touch this to the rod, pull it through. Hopefully it will go through, fingers crossed. It might take a few attempts, but hopefully it does. And once that's in, we can then wire it up, and I can neaten up the cables, and then that should be pretty much job done. Okay, so it's through. So we now got a bit of slack, and the eddy is just up here. Oh, no, hang on. It's just there. So the cable is now coming through here. I'm going to drill a little hole into the bottom of this trunking, then bring it up into the eddy. So hopefully that bit should be quite easy. Now I'm just going to go outside and quickly tidy up everything, and then come back in here and finish off the wiring. Okay, so it now comes out through this hole, is fairly neatly tacked all the way along behind the water softener, up through that pipe in the corner, into the trunking, across, and then up into the meter cupboard. So back inside, let's wire it up, and then attach the CT clamp onto the live coming in, and hopefully it works. Okay, so I've got this cable from the CT clamp ready to go. Just need to now open up the case of the eddy and get it in. Obviously before doing that, I need to turn everything off. So I'm going to turn the immersion heater off, turn the eddy off, isolate the eddy as well. I can double check that it's not turning on. I'll check it with a multimeter once it's in as well. And then at that point, I can now open the case. In fact, actually, I'm also going to flip the switch on the immersion heater in my consumer unit. Okay, so here is the CT clamp. There's two of them, CT1 and CT2, a plus and a negative for each of them. It's a funny design. There's a little push, pin that you've got to push in underneath, which then allows you to push the cable in. So it's like a push fit cable. Now, the cables on the CT clamp are really long, which I'm a bit worried is I'd rather they were a bit shorter, so there's sort of less of the single strand cable, or the uninsulated cable exposed. So I think I'm going to cut this down, strip it, and then put it in, so there's less cable, less of the black and red cable exposed. So let me quickly do that. Okay, so I think that's done. So I've installed the CT clamp into CT1. I've also just cable tied the network, my network cable and the CT clamp cable just to this grill at the bottom, just to hopefully help it from being accidentally pulled out in the future if somebody pulls one of these cables. So that should be it done. I'm going to reassemble this, and then I'll need to disconnect the old CT clamp from around the actual the main cable coming in, put the new CT clamp on, and then configure this to be able to see the new CT clamp. Right, it's a little bit dark, but hopefully you can see this. I've unplugged, or I've disconnected or removed the old CT clamp. I'm going to use this for something else in the future, and I've attached the new CT clamp onto the main power line coming in from the grid. I've ensured that the clamp there's an arrow on the side of the clamp showing the direction that power will be traveling for it to be a positive reading. So I've ensured that the arrow is facing down, because it's coming from the grid, from this main switch down into my home network, or my home system. So let's go back in, turn everything back on, and see if it works. Okay, moment of truth. Let's turn this all back on. Right, so it's back on. First thing I need to do is remove the CT clamp Right, hang on, let me type this in. Okay, so first thing I need to do is in here, I've got my harvi. Right, so my harvi is currently set up with CT1 for the grid. So I need to change that. Okay, so I'm going to change CT1 on the harvi to be none. So it's no longer connected to anything. Then I'm going to go back to CT config and change CT1 here, oops, to be grid. Grid CT check. Generation only. Grid. Okay. Don't know what this is. I might have to look up to see what that is. But anyway, grid. So CT1 is now set up as grid. Okay. So now, if I go into, yeah, you see, now I can go up. So how high can I go? To 100 amps. Excellent. Right, I'm going to leave it at 65 just for a second, because what I want to check is to make sure everything's working, and also to understand what that check, what did it say? It said grid CT check. So I'd like to just read up and see exactly what that means. Okay, right, so I finally worked out what this grid CT check means. So I did a lot of research on the internet. It's really difficult to find anything in any of the myenergi manuals or on their forums or support pages that specifically says grid CT check. Often you can find a check grid CT, which is an error that you can see when something's gone wrong. But the grid CT check doesn't seem to appear at all anywhere. Eventually, I found I found a Zappi manual that in the same menu as this had detect CT as the text for this option. And then using that, I was able to find it in an old manual. And I'll put up the little section, I'll put a screenshot up of that section of the manual now. But essentially what this option does is it's to conform with the British the DNO requirements for G100 installations. And a G100 installation, as far as I understand it, is where the equipment is designed to curtail, so to limit the amount of either export or import to the grid based on certain requirements or based on certain limits. So to conform to that G100 requirement, you have to have this grid CT check set to on. And what that will mean is that myenergi, like the eddi and the Zappi, will either restrict or prevent the charging of cars or the heating of hot water if it believes that the grid CT is not working. So the CT clamp that's monitoring the grid, the import and export to the grid is not working correctly. So that's what I'm going to do. I'm going to set grid CT check to on. And then once I've done that, I am going to go into supply grid here, down to network, and I'm going to change this import limit up to 90 amps. Now technically I could go up to 100, but I'm going to just leave a 10 amp buffer there and set it to 90 amps. So there we go. I think that's everything now set up correctly, and now the eddi and the Zappi will continue to either charge the car or heat the hot water up until 90 amps is coming into the house from the grid, and then it will start to limit the amount of power that it uses. So hopefully that gives me a lot more headroom to be able to charge my power walls and my car and the hot water overnight during that period of cheaper electricity. And here's a quick screenshot showing it actually working. So this was overnight while I was trying to charge the car, the batteries, heat the hot water, and run the house. And you can see that we're pulling in 20.1 kilowatts from the grid. That works out at 90 amps for a 220 volt supply. which is great. So that means we're maximizing the amount of energy that we can pull from the grid during the off-peak rates. You can also see that the car is charging at 6.6 kilowatts in this screenshot. The car can charge up to 7.2 kilowatts. So you can see that the Zappi is throttling the charge, reducing it very slightly to ensure that we don't go beyond that 90 amp total from the grid. So yeah, really good. Everything's working exactly as expected. Right. Thank you very much for watching. If this has been useful, please do like and subscribe. And yeah, more videos coming soon.